receive only, you do not have like mark, but only positive or negative. Okay, so for consultation we can have on 14. The time could be the same.
Okay. So I will send you a PDF file for the signature a bit later.
Okay, it's good.
Okay.
Can you send an email maybe saying what exactly we need to have ready for that day?
Okay, we are having practical works for bachelor thesis 1. So when we will have this lecture, I will explain everything what you need.
Okay.
And today I would like to go to laboratory works. Today we should have two laboratory works. It means third, network packet monitoring and analysis tools. We will be working with Wireshark and analyzing, and we will analyze TCP, IP protocol, UDP protocol, three-way handshake, and also we will analyze in laboratory 4 data link layer. It will be ARP protocol. Okay, you see in Moodle system we have virtual machine. This virtual machine you can download it. It is Windows XP, but I as told previously, this is only because the occupation of space. Windows XP, you will see it's only it's about 2 gigabytes. If you will be using maybe another operating system like Windows 8, Windows 10, it will be much higher virtual machine the size. It will be maybe 5 times bigger file. So we are using Windows XP, but the network protocol stays the same. The how to say, the protocols work in the same way. Nothing changed. So I would like to start from third laboratory. So here we have third laboratory, and we will be working with Wireshark. It's very nice tool, and if you look at, for example, another great tool is Nmap. I think you know it. It's network mapper. If you want to scan ports on the computer, you can use this tool, Nmap. And if we go here, and if we go maybe pen test, for example, maybe here we can go, not here, more basics, security tools, sniffers maybe, well, sniffers. Wireshark is in the first place. It's the best tool if you want to analyze what is going on the network. So it's the first place, because you can analyze not only wired networks, you can analyze and Wi-Fi networks. It's free. You can use it on Linux. You can use it on Windows and on Mac. It's good. And what we will use additionally, we will use not here, maybe where is I can find top security tools. Sec tools here. Okay, you see, also Wireshark is in first place for security tools. And what is interesting, we will be using Netcat. Netcat is very old tool, but it's very nice and good tool. You see, it's 996, 24 years, and nothing changes, but everyone uses it. Okay. We will go here. Where is our description? Here. We will start from Internet Protocol. It's IP version 4. Here is header of protocol. The length of the header is, you see, 20 bytes. We have here source address and destination. IP header, or we can say it's layer 3, and it means that routers, the layer 3 device, yes, router uses this protocol to to choose the right path to deliver packets to the destination. So router uses source IP address and destination IP address. Destination IP address is used to find the destination node on the network, and source address changes places when the client or server answers to the client. Yes, this places changes. Source goes in here, destination goes here. What else is interesting? For example, here we have time to live, TTL. This field is used, for example, if packet goes nowhere and can't find the destination, and it can go through many routers, and this time to live field has some integer number, for example 128, and every time when packet goes through router, this integers is decremented by 1, and when this time to live is 0, the packet is dropped. So it allows not this allow that the packet not goes infinitely through network. After time to live goes to 0, so packet is dropped. Good, and this field is very important. This field show what goes next after IP protocol, because IP protocol is used to routing, yes, and the next protocol is TCP. So usually here we have protocol number. For example, if it is TCP, we have 6 in this place. If it is UDP, we have 17. For example, it is ICMP, we have 1. Okay, next we have transmission control protocol. It's very important because I think 80% of all network traffic uses this protocol, TCP, transmission control protocol. And what is important, that this protocol is connection oriented. It means that it guarantees packet delivery. And the main part is three-way handshake. Every time when client initiates connection, these 3 packets should go in one direction and back. When client initiates connection, it should send synchronize packet with sync flag set. Here we have header of TCP, and here we have, you see, 6 flags here. And when connection is initialized, client should send a packet with sync flag set. If server is listening on the port, you see we have here we have source port and destination port. And if server is listening on that port, it answers with SYN flag set and ACK acknowledgement flag set. And again, client answers with acknowledgement, and it means that everything is successful. After these 3 packets, the data can be start sending. So it's very important. This three-way handshake is used to initiate connection. Also, what is important here, we have sequence numbers. Client initiates own sequence numbers, and server initiates also own sequence number, you see. And every time packet goes in both directions, sequence number is increased not by 1 but increased by number how many bytes server or client is sending. For example, if client is sending 4 bytes, the sequence number increases by 4, and server will answer sequence number plus 1. It means that it waits next byte. Sequence number shows the sequence of next byte. Okay, what else is important? Here we have, you see, this is sequence number 32 bits, and this is acknowledgement number, also 32 bits. And after these two headers, we have here IP header, we have here TCP header, 20 bytes, and then goes data. Here goes our payload, the data which we want to send. And user datagram is another protocol which is used to transfer usually media data. We can transfer like voice, like video traffic, transferring voice over IP. And this protocol do not guarantee packet delivery, but it's very useful because the header is small, only 8 bytes, and we don't need to initiate connection. If we are using UDP, we send packet and that's it. We don't need to check if it's delivered or not. But it's the advantage of that is that it's very quickly. We can send data, and we don't need to track the packet losses or something else. For example, if we are translating video or streaming some video, if we lost 1 or 2 packets, it's not a big deal. Yes. Okay, so how it looks in practice? We can use this virtual machine. You know what, we can use ipconfig command to see the IP address of virtual machine, and we can use Wireshark. Okay, we can start capturing here or here, and now we see what is going on the network. We can filter. For example, if we want only TCP packets, we can write here TCP, and we will be seeing only TCP packets. Also, we can write, for example, TCMP, and try to ping. I will try to ping this virtual machine from main machine. For example, ping S192.168.106, and you see. 4 packets was sent. 4 packets were sent, and we see this is echo ping request, and the virtual machine is answering ping echo ping reply. And you will see that here we have Internet Protocol version 4, it means IP Protocol version 4. So here you see source IP address and destination IP address. Yes, it's header. This part is header of IP protocol, and you see that protocol field is equal to 1. It means that here it's the hex number. Yes, it's Wireshark is decoding. 1, it means it shows here what this is ICMP protocol. Okay, and what is interesting, the payload of ECM, Internet Control Message Protocol, you see is ABCDF. It's like payload using Windows uses this payload to send in echo request. Okay, and we can use combined filters. It means that we can use, for example, ECMP, and we can write and, for example, TCP, or we can write or TCP. So we will be seeing both ECMP or TCP packets. We don't seeing anything about TCP because we do not have here. We can use, for example, browser and write here www.gtu, for example, LT. Okay, and what is going on the network? Oh, here you are seeing what is going on. Many TLS packets. What it means TLS? It's transport layer security, because the traffic is encrypted. You see here we have S letter. Traffic is encrypted, so we can see anything. Here we can see only some symbols, yes, but we can see what is going, what text is transferring between these two nodes. Okay, what else? Here we can have HTTP traffic. Here, for example, this is GET request, and if we, for example, I will try like this. I will initiate. We can send the request in AT port, not for 3 port, but in AT port here, and not using HTTPS, only HTTP, like this. Okay, and the server, you see, we send request to 80 port, but server redirect us to HTTPS. It means our traffic goes from 80 port to 883. So what is going on the network? Here we are seeing only HTTP, and you will see here we have request. Okay, here you see HTTP protocol is higher level protocol, so it means we have internet protocol with IP addresses, we have TCP protocol with ports. You see destination port is 80, we send request to port 80, yes, and source address is usually, for Windows, it's taken higher than 1024, because 1024 and less number of ports is special ports used for specific services. And usually Windows use ports high, for source port use higher numbers. For example, Linux uses much higher numbers for source port. Okay, so what next? And after TCP protocol, we have Hyper Transfer Protocol, HTTP. And here we have request. You see, here we have GET request, HTTP version 1.1, and the host to which we want to connect is VGTU LT. So we can find what here is IP address of VGTU server 158. Okay, what next? And answer is here. You see, this is server answering to us, and the answer is status 302. What it means? Okay, we can go here, and every server is answering to client. If we are using HTTP protocol, usually if everything is okay, the code is 200. It means that everything success. Status is success. But here we have status, you see, is 302. What it means? 302. You will see what this is redirection. It means that traffic should be redirected, and it was redirected. Okay, the next traffic we will see another Where is, I can't see because it's not VGTU. Okay, we will try again. Clear the old and try again. Here maybe VGTU point LT 80. Okay, and see here. We see this is not 2 times. It was why we do not see traffic to HTTPS. So we need additionally include or TCP here, and we will see what here we was redirected to here client hello secure socket layer, and you will see what port is 4433. You see, this is the redirection. Another question, for example, here I will input only TCP filter, TCP, and we are seeing HTTP. Why we are seeing HTTP if filter is TCP? What do you think? This question is in laboratory description.
Maybe because the HTTP conforms to TCP protocol?
Yes, because HTTP is higher part. You see, here we have TCP, and HTTP is higher. It means that HTTP goes like payload of TCP protocol. So we see both TCP and HTTP. And you see his TLS is also higher. Here we have transmission control protocol, and here we have secure socket layer. It is also higher level protocol. And this protocol is used to encrypt traffic between server and client. Of course, we can see first initiations. We can see that here we have some additional information. Yes, you see here is many various fields. What is interesting, here is VGTU. You see, we can use this. For example, we can write like this: TCP contains, and here we can write some text. For example, VGTU, and we will find packets which has inside this symbols VGTU. So you see here, and we can use it. For example, if traffic is not encrypted, you can easily write here password. Here you see here we do not have password. But if traffic is not encrypted, we can easily write. We can easily find packet which has, for example, password or PSV, also possible. Okay. What next? Also, we can filter many additional fields. For example, if you write TCP dot, you will see here is many additional filters which we can use. For example, we can write here TCP port equal 80. Here we will have packets which has port 80, for example. But this will be packets which has port 80 in it's never mind. It is source port or destination. We can narrow the filter and write, for example, here source port, and we will have here only packets with source port 80. Okay. What else? In virtual machine, you will find net tool, as I mentioned earlier. Here we have tools, netcat. This is tools. Also, Windows Defender, if you are using Security Essentials of Windows, yes, it recognizes this tool like hack tool. So if you use it on Windows 10, you need to allow in Security Essentials because it recognizes as a hack tool, but it's not bad. Okay, so what we need to do, we will go to netcat directory, tools, netcat, here we have netcat exe. So we can write like this, help, and this is parameters we can use. So we will open telnet, we will tell netcat to listen on telnet port. We will write like here, netcat listen port 23. It will be telnet and verbose. Verbose, it means what like debugging, showing what is going on. Okay, you see now we open port 23 and now we are listening on that port. How to see open ports on Windows system or on Linux system? The command is the same. We can write netstart. Yes, and some parameters A and N. And here we see all open ports on this machine. So we see that we have 23rd port open, and we now can connect to telnet. So go to Windows 10. If by default on Windows 10 you don't have telnet client is not enabled, so you need goes to here and features, right? Turn Windows features on off, and here you need to enable telnet client. Here put check here and okay, and now we can connect to virtual machine 23rd port, and of course we need to clear everything here, or we can leave only, for example, TCP port 23. Okay, and now here we can write IP address only 192.168.10.106. Enter. Okay, so what we are seeing here, we are seeing here three-way handshake. You see, the first packet is sent TCP, Transport Control Protocol, destination port telnet, you see 23, and flags. Flags, we have all flags, other flags are zeros, and here we have one. It means synchronization flag is set. Yes, and here we have additionally sequence numbers. Requirement is what you need to fill this table: the first packet, second packet, third packet. And here we have relative sequence number, absolute sequence number. What is different? Different is what Wireshark, too easy for user to easily view how changes these numbers. They start from 0, but this is relative, it's not real number. So we can change it by protocol references and relative sequence numbers. Disable, and you will see here real number, which is sequence number. This number is used in real. Here you see here is this number, and if we go here and press relative, it starts from 0. Okay, here is the answer. Also, SYN ACK flags are set together. Here we have SYN and acknowledgement set, and you see what source port changes. Source port now is 23, and destination is the same like was here, source telnet. Okay, and the third packet is from client, goes sequence number 1, acknowledgement 1, like in laboratory description. We see what here we have +1 +1. So the packets returns with sequence number 1. Okay, and this is initiation of connection, and connection is already opened. What next? Here we need to press together Control and square bracket together, Control and square bracket. And now we have telnet command line. We can here write help, and you see we have these commands. We can send data with this command send. Okay, and we can try, for example, send 4 letters VGTU and press enter. Okay, and you see here is our data, telnet and our data VGTU. This is 4 bytes, 1, 2, 3, 4. And so answer is acknowledged. It means that packet was received, everything is correct. And here we have 5. See, acknowledgement number is 5. It means that server receives 4 bytes and another position for waiting byte is 5th. Yes, and we can try again. For example, not here, here. Send maybe, okay, again, GTU, another packet, the same data, but acknowledgement is, you see here, 9. It means that 8 bytes was in total received. Here, acknowledgement number for server side, from server side. Server do not send any data, so here we have acknowledgement number only 1. If server will send some data, here we have higher number, like acknowledgement. Okay, and how about finalization of connection? Finalization is for disconnecting. Usually we are using 4 packets. Okay, we can write here quit, and here you see the correct according standards disconnection. It means client sends fin at the case, finalizing here. Yes, here we have fin flag set. Server is answering acknowledgement packet, and server himself sends fin at the case, and client also acknowledge what received fin and ACT packet with these 2 flags. But this is a nice and good and correct way to finalize connection. Usually browsers do not send this sequence of packets. They like very quickly disconnection, so we are sending RST packet, reset packet for disconnection. So it's not according standards, but works also, because reset packet, it means that connection is closed. And for that, it's enough to send only 1 packet and not need to send these 4 packets. That's not very nice way, but it's possible to save traffic. Okay, so you saw okay. So this is how connection is initialized, how data is sent, and how we disconnecting from server. So everything you need to fill in here.
Maradona died, yes.
Here. So what you need to provide in report, here we have content of report. So you need to include in report tasks. Here is the number of tasks that you need to provide answers. You need to take print screens and write what we need to look. For example, you not only need to provide print screen but you need to mark the places where is the answer and explain, not only print screen, but describe what we need to look at and what we need to find in that print screen.
Excuse me, can
Yes.
you share the screen?
Okay. Yes, I forgot. Okay, here. I will show again. Here we have content of report. Yes, and here we have task numbers, which you need to answer. What else? For example, what is going on when the port is the port is closed? For example, you see here that the connection is closed. Netcat is not listening. We can check it. Okay, you see 23rd port is not opened, so we can go here and again we will try to connect to the server, and you see that sync packet was sent here. Yes, sync packet was sent for connection, but the port is closed, so server is answering with RST acknowledge. Acknowledgement, it means acknowledge with this sync packet, and RSTs mean that the connection should be not possible to connect because port is closed. And telnet is trying how many times? 1, 2, 3, 4. Trying reconnect 4 times. Totally 5 sync packets was sent. Okay, so how about UDP? What is about UDP? We can change. We can add some other parameter here. U parameter, UDP mode, and for example, we can change port 555 and add parameter U. Okay, and now Netcat is listening on port 555 and the UDP protocol. You can check it, and you see UDP here 5555. Yes, and we can refresh our Wireshark, and we can try to send here using Netcat some data. For example, I will change to directory download. I not here. Users, user, download Netcat. Here we have, yes, Netcat 2, and here we have additional, you see this file testos. We can see what is in that file. For example, testos. We don't have cat command on Linux. Maybe we can, how we can echo? No? Yes, echo it's testos. How we can look inside? Who remember? How we can look inside?
Nano?
Nano is for Linux, not Windows. Yes, Windows, look inside. Look inside file, command line. New content. I forgot the command.
Isn't it just without any command, like just
possible.
spell the name, just testus.txt and it should open?
We will try like this. Yes. We have command more, and also I think we have command type. Testus, yes. 2 commands can be used. So inside we have Word Tinkla in Lithuania, it will be in English networks. Okay, we will try to send this content using netcat. So we can do it. Here is the command. Here we can write like this: netcat UDP, host IP address, port number, and file name. So netcat UDP, host name will be 168.10.106, port number 5555, and testers. Okay, here everything is okay, connected, so we can try. We don't see anything. Why? Because
the filter.
yes, because of filter. We can write here UDP. Oh, so many. So we can try UDP port equal 555 here. You see, this is only one packet, nothing, no session initialization, no session finalization, nothing, one packet. And here is our data in hex format, and here our in text format, the same word. Okay. You see, this is very simple protocol. You send data and that's it. No acknowledgement, no session initialization. And okay, we can try to close here received data. We will close connection and try again. Okay, and here we will try again. And what is going on? You see, if this protocol is not filtered like with firewall, you will receive answer. And ICMP protocol destination unreachable, port unreachable. It means that port is closed. But usually many firewalls filter this packet, so you can send UDP but receive nothing. Okay. And what else? I think this is all about this laboratory. Of course, I show only the main parts what you need to know and do. There are much more what you can try. Okay, and now we will go to laboratory 4, and here we have ARP protocol, and I will show you. Okay, we can write here for example ARP filter, and every computer inside has ARP table. For example, ARP-A, here we have ARP table. This is table of available nodes on the network, and where we have MAC addresses. Here you see. We can clear the cache of these addresses with command, for example, ARP delete. Of course, we can write hash, H, it means help, and see possible parameters. And here we can write D, and again check ARP A, and you will, another packet is here, so we can again delete it and check. You see, computer is by himself trying to initiate connection. I think the problem is with web browser, which I think is trying to have connection. So I will close the browser. Okay, and try again. And yes, it's empty. And we can clear here. Okay. And I want to show you the process of ARP protocol. Okay, I will try to ping gateway 10 and gateway the first address. Okay, and maybe or ACMP here. You see that before the computer starts sending packets, it initiates ARP request here, ARP protocol. And here we have destination address of many F letters. It means that it in binary it all ones here. So the destination address of all ones, it means that it's broadcast address. So this packet will be received by every node on the local network, and only the node, only computer which has IP address specified in ARP request will answer here. Only one receive this request all computers, but answer only one computer. Okay, and we can see that address resolution protocol has sender MAC address, sender IP address, and target MAC address. It's 0 because it do not know who has this, what is the MAC address of this IP address computer. So computer with this IP address answering to this request. So answer is from, you see, from 10.1 from gateway, and it includes all MAC address here. So only now computer can send ping request. It's the same, not only ping request, but it's the same if you would like to send the HTTP request or any other packet. First of all, in local network, computer should know the MAC address of destination. It's very important. And what next? For example, at the moment, we can look at ARP table. ARP. Nothing here. If nothing here, again, if I try to send ping packet, it starts from ARP request and again ICMP packet. But if we here already have MAC address and we will try to ping, okay, we will try to ping again, and you will see that ARP request is not sent. It starts sending without ARP request because MAC address is into cache here. Okay. What is interesting? We can, for example, make fake MAC address here, and if we make fake address of gateway, every packet will go to fake address and the destination will not be reached. So it's very, you need to be very carefully because this type of fake addresses is very hard to find. For example, if you change for in computer this IP, this MAC address, for example, in this table, and write that this is not dynamic but static. So if you forgot that, you will not be able to reach, for example, internet. So if you can try it, but do not forget to delete this record. Okay, what else is interesting? For example, if we delete everything here, our cache is empty, and we will try ping not from virtual machine, but from main machine. From here, we will try to ping here, and you will see that computer which receives the packets also stores the MAC addresses in his cache. So and when it's answering, it already has MAC address and can answer to the sender. And it's very good because if in other way, if the cache will be empty and our MAC address is not known, so another ARP request should be sent. But if this node by himself saves this MAC address in his cache, so we can save 2 packets on the network. So it's very good. Okay. Okay. What else? I think this is also, I told you main things what you should know about that, and the structure is the same. After all these tasks, here we have content of report, and here we have tasks what you need to complete and show the answers to this task. Show the process, how you reach the answer, how you do this task. Okay, have you any questions about these laboratories? Do we have any question?
Will we cover multicast as protocol?
No. In this laboratory, we do not have multicast. Only main protocols. Okay, so you need for next time you need to do these 2 laboratories, and if you will have some questions, so next time we can try to solve if you have some problems with these 2 laboratories.
Sir, I have downloaded the VirtualBox for Windows XP, but I have an error. It's telling me that the network adapter, I don't know, is missing or not working. So it can't launch the Windows XP. It's telling me Gigabit Ethernet adapter.
So you can change. You can use different, for example, here.
I changed the adapters of to anyone. They are not working at all.
It's very strange.
I can show you if you like.
I think you forgot to change the thing in the virtual box itself. You have to specify which network do you provide to the virtual box.
Yes. Here we can change, for example, bridge adapter.
Yes, this one.
You can
I was changing this one.
But you can change here. You have many adapters. You can use different adapters.
Okay, let me check. Am avut 6 ocazii și el tot la fel.
Try to choose right adapter for you.
Whatever I choose, nothing happens in the bridge adapter. I can show you if you'd like.
Okay, try to show.
Back to meeting, share screen. Let's go. Why is it working? It was start now. Or it's not working. I don't know. Man,
we have very echo.
Can you mute it?
Okay, try to share your screen.
Share an entire screen, not just a program.
You have difficulty to share your screen?
No.
But you are sharing, you try to share screen, all screens, so we will see all windows, because you are showing only one window.
I'm sharing this one. Just a second. Virtual. Se mișcă mai bine.
Nu instant, dar stai tu să vezi dacă e, dacă în ultima clipă nu trebuie să selectezi, că după aia n-ai ce să fac.
Could you see the error?
No, because
No.
you're sharing the application and not the entire window.
Wait, just let me see because I don't know. This thing is, I don't know what's wrong with it.
It should be named screen 1, not the application.
Wait, because share screen. I don't have screen 1. I have Oracle. Yeah, this one, I guess.
Da, ești prost.
It's the same
Ești
thing.
prost. E și român. Ești prost rău.
This
Okay.
works, yeah.
Mhm.
Yeah, if I set, okay, I cannot change.
You should stop virtual machine. Stop virtual machine then.
Okay.
Stop okay. Stop virtual machine and change
Bă,
adapter. And
Okay.
then try to start again.
Okay, thank you. Network operation manager. There's no.
Anybody else has like this problem, or you are trying to, everything is okay for our student?
Everything. Everything is fine.
Oh, good.
But I have a small question in laboratory too.
și eu.
Okay, please ask.
E și român asta.
Nu e român, e kit-ul meu de deplasare cu aia. Am ambele kit-uri de la România.
I couldn't finish task number 18 and 20.
18. Okay, we'll try here. 18. 18. I will try to share my screen here. Yes.
This one, yeah.
Yes.
ABC.
Okay. So we can try to solve the problem. Maybe somebody else can help. Okay, the main idea is here that router divide network, separate networks. And for example, here we have IP addresses of this part of network. Here we have another part. So if you look at this part, it's 135.250, yes? And this part is the same here, because the subnet mask is 255.255. It means that we are in the same network. It means that this computer and this computer is the same network. But here we have router. So what we need to do, we need separate networks. So one can be, for example, we can use here 255 and here 255. It's the easiest way to fix this problem in this part of network, in A task.
Okay, okay.
So in that way, we here will have, you see here 84 and here 59. It means what is different network now.
Okay, now I understand. Okay. This
Yes.
one.
And this is the same situation here. You need to find the problem,
Okay.
and here you need to find the problem. Okay, it was 18, and another one was problematic. Yes, which one?
To end. 1 second.
20.
Yeah, 20.
20. Okay. The solution is here provided. I will show you here.
I didn't understand that.
You do not understand. Okay, we will try not here, but here.
This one.
Yes. And maybe do not have exact. So the MAC address is first separated into 24 bits, which one being okay. Okay. So we need separate. This part goes here, this part goes here. And here we need to write FFFE. Okay. And we look here. You see, this is FFFEF, this part. So here is example, and look again here. We will try to solve this. 0.21 to A. Okay. Mm-hmm. 21 of A. Yes, 0, 1, 8. 3 here to 8. This is this part is because of local network, and here we have 8, 3, 2, 1, and this part is changing according this. You see what this bit, second bit, not second, first bit, because this is 0 bit, first bit is changed from 0 to 1. So here we have, in this part, we have not A, but it's inverted. So we have 8. Okay, I will try to write. I will open some maybe paint. I will try to show you. PowerPoint. Maybe I will open. Okay. Okay, where is my PowerPoint? Here. Here. Oh, now you're seeing empty.
Yes.
Empty page. Okay. Now we will try to convert. Okay, I will open. I need to see all numbers. Wait a little bit. Okay, there is number. Where is number? Here. Okay, I will write here. Why we have okay, the all here 83 B D E9 and CF. Okay. According description, what we need to do, we need to divide this part into 2 parts. It's one part, yes, and this is another part. and here we need to put F,
EF.
yes, EF, FE, according our laboratory description. Okay, what next? Next we take this one. Okay, back, we take this one, and here we have in binary like this 0, 0, 0, 1 and 1, 0, 1, 0. And what we need to do here, we have this bit and we need to invert it. So we have 0, 0, 0, 1, 1, 0, 0, 0. So here we have 1, 8. Yes, and it means what here we have 1, 8, 2, E, 8, 3, and here nothing changes. B, D, E, 9, C, F, like this one. And what else? Here we have for inside networks, usually we have I will show you where is here. For inside networks we have, okay, I delete this.
So we only change the second.
Yes, yes. And here we have for local IP addresses, usually it starts F, maybe big letter, F, E, 8, 0, like this. Then we have these two dots, we have 4 numbers, we have another 4 numbers, we have another 4 numbers, and like this. I will show you on the network. Okay, IP version 6, special ranges, and we will try to see. Yes.
So in the task we have only local addresses, so it should start
Yes.
with
FF, yes, FE80. You can try to Google try to Google and Internet Protocol version 6 special special addresses, and you will find the ranges for that.
So in the task, in this one, it was given EFBD. Is that wrong or?
Yes, this is wrong. It will be FE.
All right, thank you very much.
Incorrect, yes. It should be, yes, it should be, I will check again. I think it should be, okay, again, I will check it. FE, everywhere I see FE, so it's mistake, it's my mistake.
All right, no problem.
Yes. Okay, do you have additional questions? How about this one? How you will write here? I don't see. Sorry. I will share my screen again. Here. Here. How about this one?
1 second. I sent it in the chat.
Okay. It's correct. It's very nice because you can do here. You can you should or here leave zeros or here leave zeros. So it's very, very yes. It's correct. Very nice. Good. Do we have additional questions?
No.
No, everything is clear. So good. So thank you for participation, and we will see you next week.
Final question. How many labs do we have to do?
All labs included in Moodle system.
And we should. There's a date. We should all report, report, make a report.
Yes. Report is before. I think the last week of our lecture how to say period. It will be okay. I can check. I think next month. Next month, I will share screen, entire screen, and I think it will be next month this week. Because you see, this week is always holidays. We can have, so this week it's the last week.
So it's like from 14 till 18.
Yes. In this week, you need to have reports because this is holidays. Yes, this is vacation, and here is session. And of course, the final date, the total final date, is before exam. Before exam, you should be already finished with laboratories.
Suprato, ačiū.
Ačiū. Very good. So thank you for participation, and we will see next week you.
Thank you, Professor.
Iki pasimatymo.
Iki pasimatymo. Thank you.
Bye.
Bye.